All right, so in the last video that you just watched, you learned how to complete the square. So I'm going to review that a little bit, but also extend that into how we can use that completed the square equation, that vertex form equation, to find the vertex and sketch a graph of the quadratic. From what we know of its parent function, we can sketch a graph. Miss Von Tillius and I organize our completing the square a little bit different. It's the exact same process. And either one, both of us will accept either method, so you do what works best for you. But when I complete the square, I like to put the first two terms in parentheses. So I'll put x squared plus 2x and then a plus blank inside parentheses, and then the minus for that last term and the minus blank on the outside. I know she underlines it. It's the same thing. We'll get the same answer at the end. It's just a difference of organization. So then to figure out what term goes in here, there's an equation. We can use b divided by 2 and square it. So b in this case is 2. 2 divided by 2 would give me 1. 1 squared gives me 1. You can also think about it from a logical factoring standpoint. If I want two terms that are exactly the same, that means that both terms need to be the same and add to give me 2. Well, the only terms that are exactly the same that would add to give me 2 would be 1 and 1. So that means 1 has to go here, right? 1 plus 1 is the only way you have two of the same terms that add to give you here. So then 1 times 1 would give you my term here. So then if I factor what is on the inside, I just did that here when I talked about 1 and 1. So this would be x plus 1 squared, and then minus 4 minus 1 would give me negative 5 or minus 5. So this would be my vertex form. This is what I get when I complete the square. So now if we think about this as a quadratic in its transformations, this plus 1 would mean I took my graph left 1. And then this minus 5 means down 5. So if we think of the point on a graph, on a quadratic, remember our quadratic looks on a normal, our parent function would look like this. So normally that vertex is at 0, 0. So if I move it left 1 and down 5, I would be here at the point negative 1, negative 5. So my vertex would be negative 1, negative 5. All right, if we try another example, so again, I'm going to put the first two terms inside the parentheses with a plus blank, and then on the outside, I will have the minus blank. Remember to keep our equation, right, to make sure this equation stays equal, whatever I add to it, I also have to take away from it. So that's why we need a plus and a minus. We can't have a plus and a plus because I need to keep the equation balanced. So then to figure out what term goes here and here, it's the same thing in both spots, but to figure out what goes here, I need two numbers that are exactly the same that would add to give me negative 6. So that would need to be negative 3 plus negative 3. So then negative 3 times negative 3 is what goes here. When we think about factoring, we say what multiplies to get here and adds to get us this term. So negative 3 times negative 3 would give me positive 9. So 9 goes here and here. If you prefer to use the equation, right, b divided by 2 squared would mean negative 6 divided by 2, which would give me negative 3, and negative 3 squared would give me 9. So either way you want to think about it, you would get that same answer. So then if I factor this inside piece, what multiplies to give me 9 adds to give me negative 6 would be negative 3 and negative 3. So negative 3 squared, and then positive 7 minus 9 would give me negative 2. So this would be my equation in vertex form. So now I can figure out what the vertex is from this equation. So this minus, if we think about the transformations, this minus 3 is going to have me go right 3, right? A minus 3 on the inside is a right 3. A minus 2 on the outside is a down 2. So if I take my vertex, which is normally 0, 0, and I go right 3 and down 2, that would give me the point 3, negative 2. What you might have noticed from these first two examples is that the first number that became my ordered pair changed signs, right? Because this left one, it's actually at negative 1. And then the last term stays the same as part of my vertex. So +1 became -1, and then this stays -5. -3 became +3, this stays -2. But if you think about the transformations and where that 0, 0 is moving, that can also help you find the vertex. So go ahead and pause the video and work on number 3, putting it in vertex form and then figuring out what that vertex is. All right, so when I did this one, again, I put the plus blank. I left room inside my parentheses for whatever I was going to add here, and then that same thing I'm going to subtract out there. So then two numbers that would multiply to get or add to give me -14 would be -7 and -7. I need them to be the same, so then -7 times -7 would give me 49. Or if I use my equation b divided by 2 squared, -14 divided by 7, -14 divided by 2 is -7, -7 squared is 49. So I added 49 here and subtracted 49 here. So then when I factored this, I got x minus 7 squared, and 15 minus 49 would give me -34. When I think about the transformations, a -7 means right 7, and a -34 means down 34. So that vertex would be at 7, -34, which again, I changed the sign of what was in the parentheses, and I kept the sign of what was on the outside. So that was just a quick review of the last video. We're going to do the same thing for these next two examples, but we're going to use this vertex form and what we know about our transformations to help us graph or sketch a graph of our quadratic. So we're going to complete the square so that we can find our vertex. So I have y equals x squared minus 6x plus blank plus 10 minus blank. So then again, I can do my b divided by 2 squared, or what two numbers that are exactly the same add to give me -6. I would need -3 plus -3. So then -3 times -3 would give me +9 here. So then that's going to factor to x minus 3 squared plus 1 would be my vertex form. Right? What multiplies to give me 9 adds to give me -6 would be -3 and -3. That's why we get -3 squared. And then +1 or 10 minus 9 would give me +1. So from here, we know that this is a quadratic who moved, this -3 would mean right 3, and this +1 means up 1. So normally my vertex is at 0, 0. I went right 3 and up 1. So now my vertex is at 3, 1. Remember, change the sign of the term on the inside, keep the sign of the term on the outside. So now that I know my equation and I have my vertex, we know the general shape of a quadratic. So we're going to just sketch that piece. Another thing we should have learned from Algebra 1 is our axis of symmetry. The axis of symmetry simply breaks your graph in half. So it is the line that runs up and down that tells that whatever happens on this side is exactly the reflection of what is happening on this side. So these two sides are symmetrical. So for this problem, it goes straight through our vertex. So our axis of symmetry always runs through our vertex. And then whatever we do to one side, which is going to be just a little sketch like this, is going to be exactly what happens on the other side. So there's my sketch like that. So we're roughly trying to make both of these sides symmetrical. That makes our axis of symmetry x equals 3. It's an equation, so we have to have x equals, and then whatever value that line went through for our x value. So that was x equals 3. The axis of symmetry will always be the x value of your vertex because your vertex is where your graph splits in half. So then we roughly sketched what this graph looks like. So now we can figure out these last 4 pieces. So domain and range. Domain is my x values. So since this graph is going to keep going to the left forever and to the right forever, my domain is -infinity to +infinity. Then my range is from the bottom of the graph to the top of the graph. So if we look down here, we're not using any of these y values until we get to the y value 1. So my graph starts, its y values at 1, and then it keeps going up forever, meaning it's going to go from 1 to infinity. And we have that bracket on 1 because 1 is included, the value of 1 is included in our answer. So then as I think of end behavior, as x goes to positive infinity, so as x is heading this way towards my positive x values, yeah, that would be the right side of this graph. My arrow is pointing up, meaning it's going towards positive infinity. And then as I go towards my negative x values, this way, my graph is also pointing up, so its end behavior is also positive infinity, right? If my arrows are going in the same direction, my end behavior should be going in the same direction. All right, if you want to pause and try number 5 on your own and see if you can get this all by yourself, that would be great. If not, we're just going to go over it together. So the first thing we did was complete the square so that we get the vertex form, right? This is the standard form of a quadratic. We need it in vertex form to be able to graph the transformations. So I have y equals, and then I put in my parentheses, x squared plus 4x plus blank minus 1 minus blank. So then to figure out what this term is, I take b divided by 2 and I square it. So that would be 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared would give me 4. So that means 4 goes here and 4 goes here. So then I'm going to factor this inside piece that's in my parentheses. So what multiplies to give me positive 4 and adds to give me positive 4 would be 2 and 2, positive 2 and positive 2. So I can just square that because it's the same factors twice. And then negative 1 minus 4 would give me negative 5. So here's my vertex form. So from there, looking at our transformations, this plus 2 means I went left 2, and this minus 5 means I went down 5. So I'm going to move to the left 2 and down 5, which tells me my vertex is at negative 2, negative 5. Remember, we change the sign from the inside term. We keep the sign of the outside term. All right, so then my axis of symmetry is that straight up and down vertical line that goes through my vertex. That is splitting my graph in half. That's at the x value, negative 2. Remember, it's always the same as the x value of your vertex. So that means whatever I'm doing on this side of my graph is what I'm doing on this side of my graph. And it's just a rough sketch of what our graph looks like. We know the quadratic is a U shape, so we're roughly making a U shape. And then once we have our sketch, we can use that to help us find our domain, range, and our end behavior. So our domain, our graph is going to go to the left forever and to the right forever, so it's going to use all of our x values. So our domain is negative infinity to positive infinity. And then our range is bottom to top. So I'm going to do the bottom. If I start at the bottom, I'm not using any of these y values until I get to the y value, negative 5. So my graph's y values start at negative 5 and then continue up forever, right? These arrows are both going up, meaning I'm going to use the rest of those y values to infinity. So then if we think about our end behavior as x goes towards positive infinity, so as I head to the right side of my graph, the right arrow is going up, meaning my end behavior is positive infinity. And then as I go towards negative infinity, my arrow is also pointing up towards positive infinity. So my end behaviors are both going up, so my end behaviors are both going up towards infinity. All right, so hopefully this gave you an idea of how to convert it to vertex form to help us sketch our graph. You can go ahead and finish the back of that worksheet that we gave you in class.